Actually, in today we'll start with few problems that can be detected, errors that can be detected using proper generator. Generator is what? The divisor. The divisor using which you can divide the what data word, okay, or the divisor which is shared between sender and the receiver, which we studied under cyclic codes. Okay, so now we'll see what are the different kinds of errors that can be detected with the help of choosing proper generator, which is nothing but divisor. Okay, so now the first thing is single bit error. So if you design generator properly, then we can detect single bit error. Okay, so it says that if the generator has more than one term and coefficient of x0 is 1, okay, all single errors can be caught. Okay, so here the generator is what? Generator is nothing but divisor. Okay, as more than one term, what does it mean? And the coefficient of x0 is what? That means, see here, one second. Huh. See, if whatever you consider the generator as, this one, yeah. See, if you consider generator as x power of or plus 1. Okay, so if the generator has more than one term and the coefficient of x power 0 is 1, all single errors can be caught. So if you use this kind of divisor, then single errors can be used. Single errors can be detected. That means if any single errors are present in the data which is sent over the transmission link and received at the receiver side, okay, and when you apply the cyclic code, where you perform division operation, while dividing, if you choose the divisor as one term, that is this one x, okay, and the coefficient of x power of 0 is 1, then if such generator, if you use, all single errors can be caught. Okay, that is what it says. Next is okay. So sorry. So next, let's see. Yeah, example, that is which of the following, that is g of x, which is nothing but g of x, which represents what? Generator. Okay, or you can say generator polynomial, or you can say divisor. Do remember, the divisor is represented in the form of g of x. Okay, so now the question is, which of the following, that is g of x. See here, a, b, c, what they have given is all the generators, or you can say divisor. Okay, so here, which of the following generator values guarantees that a single bit error is caught? So out of these three, or if you use a, will it detect single bit error? Or this b1, x power of 3. If you use x power of 3 as a generator, then will it detect a single bit error? Or if you use 1 as a generator, will it detect single bit error? That one you have to check it out. Let's see. So the first one, x plus 1. Okay, so this detects single bit error. How? So we already seen that here, if the generator has more than one term and the coefficient of x power of 0 is 1, then all single errors can be caught, right? So whatever expression, the generator that we have considered here, that is x plus 1, this detects single bit error. Okay, I hope you understood. Next, x power of 3. Next question is, next generator is x power of 3. As you know, it doesn't have statement, it doesn't follow the statement which I just explained in the beginning of this class, right? Cannot detect single bit error as coefficient of x power of 0 is 0 here, right? The last term where we had written +1, no, that is not there here, that is 0. That's why this generator polynomial cannot detect single bit error. Okay, next, the last one, 1. Obviously, this is not in the form of what, x plus 1 or something like that, right? So this, the third one, generator polynomial cannot detect single bit error. Okay, the reason is also written here, as more than one term is not present. There is no the next term in the given generated polynomial. Okay, so that is how you can make decision on this. Okay, next type of errors that it can detect is two isolated single bit errors. Okay, you can see in the image where the bits are written. Okay, and here from left right side, that is 1 1, which starts with 1 1, right? That represents x power of 0, and the last term that represents x power of n minus 1. And you can see in the image, which is highlighted here with the help of yellow color, the x power of j and x power of I. Okay, these two are the single bit errors, but it is two isolated single bit errors. Okay, so these are the two isolated single bit errors. So the now question is, whatever generator polynomial that we consider, will it detect such type of errors? Okay, so for that you have to remember, if a generator, what is generator? Divisor that is shared between sender and the receiver. Okay, if a generator cannot divide x power of t plus 1. Okay, please remember, if the generator, whatever generator that we consider, if it cannot divide x power of t plus 1, okay, where t can take the value from 0 and n minus 1, then all isolated double errors can be detected. Okay, so if the generator you consider, if it cannot divide x power of t minus t plus 1, then it will detect all isolated double errors, okay, in the given data. Okay, now see, we'll see if just remember this point, okay, so that you can solve the problem. So now the given question is, find the status of the following generator related to two isolated single bit errors. So here 4 different generators they have given. Okay, now the question is, which are all the generators which are given here will detect two isolated single bit errors. Okay, now let's consider the first one, x plus 1. Okay, this x plus 1 cannot detect the errors because it is because as it is in x power of t plus 1 format. Please remember the statement that I have mentioned in the previous slide. Okay, so here this given polynomial generator cannot detect, it cannot detect as it is in x power of t plus 1. Okay, see here generator x, here t value is 1, x power of 1 plus 1. So the given polynomial generator is in this form, x power of t plus 1. It cannot detect two isolated single bit errors. Okay, next. Second one, that is x power of 4 plus 1. Right, the same, this also is this also is in the format x power of t plus 1. So it cannot detect
two isolated single bit errors. Okay. Third one. Third given polynomial is polynomial generator is x power of 7 plus x power of 6 plus 1. Okay, now you can see this is not in the form of x power of t plus 1, right? So this divisor or the generator can detect two isolated single bit errors. Okay,
It is easy to remember, right? So the fourth one, given generator is x power of 15 plus x power of 14 plus 1, right? So even this generator is also not in the form of x power of t plus 1. So even this generator polynomial can also detect two isolated single bit errors. Okay, so that is about finding two isolated single bit errors. Next, we'll move on to finding burst errors. Burst errors is what? Where two or more bits might have changed when it is delivered at the receiver end. Okay, so now let's start with this. Let's consider if L is burst size. Okay, L is burst size and R is the degree of generator polynomial. So what is degree of generator polynomial? See in here, you see the D, the given generator D. Okay, x power of 15 plus x power of 14 plus 1, right? So here the degree of polynomial is 15. That is the highest degree in the given generator, right? So considering D, you can say that x power of 15, 15 is the highest degree present in the given generator. Okay, that's why the degree of polynomial is 15 here. So keeping that in the mind, R is the degree of generator polynomial. Okay, this is the given thing. Next, all burst error. So what are the burst error that are present in the data with L lesser than or equal to R will be detected. Okay, so if L value, L is what? Burst size. If the burst size is lesser than or equal to R, that is degree of the generator polynomial, then all burst errors can be detected. Okay, next. Now, all burst error with burst size as L, which is equal to R plus 1, will be detected with probability 1 minus 1 divided by 2 whole power of R minus 1. See here, you have to remember these statements, then you can find solution for the given problem. Okay, the last one, all burst errors with L is greater than R plus 1, then it will detect all the burst errors with the probability 1 minus 1 divided by 2 whole power of R. Okay, so these three things you have to remember to find burst errors. Okay, next, let's solve few of the problems here. Find the suitability of the following generators in relation to burst error of different lengths. You can see here the different generators are given. So now the question is, using this generator, can you find out burst errors present in the data? Okay, so let's see first one, x power of 6 plus 1. Okay, where here what is the degree of polynomial? That is highest degree present in the polynomial, right? So it is 6. So our value is 6 here. Now let's find out burst errors. First thing is what? All burst errors